anybody else have a book to do some dramatic reading? Nikki, read to us.
It says, what is the mass in grams of 10 million SO2 molecules?
Okay, so you didn't get it like that. You got 10 million. Now, was that words, or did it have the big number all written out?
The 10 million was written out. Or it wasn't written out like that, it just had the words.
It just had the words. Okay, see an extra step in here. 10 million. Okay, I would do that, and we've got ourselves 10 million. So what I did, I simplified that. I moved from the words 10 million to that. Now, I probably went through that thinking first and decided, okay, 1.0 times 10 to the 7th, and I chose to keep 2 6 there. Okay, now, what are we going to do with that? If you look over here, this is going to give you a nice clue. Think where you are. See, element or compound here we're messing with. Anybody? Compound. Okay, so we know this is our guideline. So you can always reason it through. I mean, you could be thinking, okay, if I had 6.02 times 10 to the 23rd of the molecules, you know, that would be a mole, and I could go from molecules, and I could find out what part of a mole I have. Okay, if I know what part of a mole I have, then I can go back and think about how many grams I have. I mean, that's thinking it through. Here's your automatic pilot, because it's going to be done like this. So, let us begin here. You think, you're right here. You want to get way back over to here. And this is probably the most challenging one in this section. Similar to, we did one last time together. 1 atom of iron. How many grams was that? Well, you were here. We took it way back there. So this compares to that one, except now we're dealing with a compound. Okay, so let's go with it. What's the first thing I ought to do? Pedro, how shall I start this thing?
1.0 to the 10th power,
Okay.
times 10 to the 7th power divided by, split that all over 1,
Okay, I can do that.
and then you can put 1 mole is 6.02 times 10 to the 23rd power,
Okay. What would be the units on this?
molecules.
Molecules, good. Now, you could shortcut that if you wish. And, you know, just since that says just go divide, you could. And then your units would be a complex fraction, because molecules and molecules cancel, moles come around on the top. So what Pedro just did for us, this is more similar to the unit analysis way of chapter 1. So either way is fine. Now, let's not stop there and get an answer. Pedro got us to here. Now, if I want to go on, Tran, what do I need to do? Okay. Now, formula weight of that, we could set up a table, but when the molecule is so small, sometimes I bypass that, but let's go ahead. SO2, 1 sulfur. Okay, look up there. Russell, what shall I use to the nearest 10?
32.1.
32.1. So sulfur makes the contribution of 32.1. I have 2 oxygens, and each oxygen makes a contribution of what, Clint?
16.
Okay, point?
0.
0. Okay, you probably, one that tiny, you probably could have just kept it running in there. So, Timothy, what are we getting here for formula weight?
64.1
64.1, what are your units?
grams per mole.
Good. Grams per mole. And our thing over there tells us to go multiply. So it's 64.1 grams in a mole. And here's your safety net, how all those units cancel. That leaves us with grams, and that's what it asks for. So, whichever way you choose to do it, for this first part, you know, you multiply, if you're rusty, multiply the tops across, get an answer, multiply the bottoms across, of course you just get this, divide the bottom into the top, and let's hang on to 2 6 here. So, Aaron, what'd you get? 1.1 times 10 to the minus 15, and what are your units? Grams.
That's not what I got.
Okay, what'd you get?
I got 2.6 times 10 and then 19.
Okay, I don't, that's, okay, Tran, what'd you get?
I got one, well, I got 1.3, I put 360, so it's 1.36.
1.36?
I got 3.6, I put 1.06 times the negative.
Okay, let's just go 1.1 because I just arbitrarily chose this because when you got a number like that, you don't know. You know, Al would say that's 1 sig. Our textbook says you don't know. You don't know. Okay, so let's go for 1.1. Now the real issue is, how's the power? Is it minus 15?
Yeah.
Okay. Okay. Aaron, why don't you repunch that? Did you, oh, you had this? Okay, it's Andrew that needs to
Yeah,
repunch.
I divided instead of multiplied by accident.
Okay, okay, that's why you're sitting here punching this through, to find out your mistakes now instead of on test day. So we can get it cleared up. So it's fine to make mistakes today. On test day, it's not so fine. Now, I want you to think about this. We've got this many million molecules. Let's go ahead and write that. 10 million molecules. That sounds like a huge number, doesn't it? Look at the mass. If I didn't lose track, we don't have a balance to cope with that. In other words, that should give you some idea. The molecules are really tiny, aren't they? That if 10 million of them only weigh that. So if you got enough to work with, you got a load of molecules there. All right, now we're ready to move into this. And I think I hinted at that a little bit. Didn't I talk about empirical formula and molecular formula?